So today we're going to go and measure most of the different components on this board and see if they're still any good from 1978 to 2024. See if they're still healthy. So it's a great little test of this. You can get them from eBay and those sorts of things. Only costs 10 or so pounds, and it can test all sorts of things: resistances, transistors, diodes, capacitors, inductors. Seems pretty accurate. It's a great little tool. Let's test some of the components. Let's see if they're still any good after 47 years. We'll start with the capacitors, electrolytics. So this one says 3 microfarads. Let's see what the test says. 7 microfarads. Interesting. What does a 10 microfarad measure? 14. Okay. ESR is not brilliant, but it is ancient. 100 microfarads. 123. Again, the ESR's pretty bad, but maybe that's what caps were like back then. Let's see what the tester makes of a germanium diode. Doesn't seem like a low voltage drop to me. Let's measure the transistors now. The board says this is a 2SA52, but the device is actually marked A201, so I guess that's an equivalent. So let's see if it will recognise this. This should be a germanium PNP transistor. Just move that wire out of the way. Yep, it did. It got it. Oh, how can we get that on the lab? There we go. PNP, 0.247 millivolts of forward drop and a gain of 29, or HFE. Let's try the other one. So this one is marked B175, which must be an equivalent to the 2SB56. Yep, another PNP transistor and very low forward voltage drop as expected from a germanium transistor. HFE seems awfully high at 203. There we go. I wonder what the solar cell will measure. Hmm, 3.5 volts. So here's the solar cell open circuit voltage just with the room light in the background, and now if I put the lamp on, yeah, it's nearly half a volt. I suppose that's reasonable for one cell. Let's test the CDS cell, cadmium sulfide, when it's illuminated. About 2K. Okay, let's retest with it in the dark. $64K. That's pretty good. Let's test the tuning capacitor next. It's turned to fully anti-clockwise at the moment. Let's see what that gives us. 254 picofarads. Let's wind it all the other way. It says no unknown or damaged part, but the capacitance may be too low for this meter. So let's turn it back just a little bit and press it again. about 60 puff. Okay, that's quite a wide range of capacitance. Right, let's measure the inductance of the antenna coil, ferrite rod. 0.32 millihenries, 320 microhenries. That's about what we'd expect. That's good. Right, let's measure the potentiometer, mark control on this board, see what that's like. So with it wound all the way anti-clockwise, 45k and 23.9 ohms, which is sort of what you'd expect. Let's set it to the middle, and we get about 23k. Okay, that's about right. And all the way up, all the way clockwise. 3 ohms and 45k. Super. Right, next let's have a look at the audio output transformer, sometimes known as an LT700, I think. Let's see what happens when we measure across the whole primary. .62 ohms, 1.4 millihenries, 1.4 henries in fact. That's a very high inductance. Not sure quite how high it should be, but I'll have a look at the data sheet later. Now we'll check out the secondary side. Right, let's see what the secondary side of the transformer measures. It should be a low impedance because it's driving on a low impedance speaker. Two ohms, 10 microhenries, very low. Let's see what the loudspeaker does on this tester. Made some funny noises as the test is being done. 11 ohms, 50 microhenries. Yeah, I guess that's okay. Let's measure the cold resistance of the signal lamps. See what they're like. .43 ohms. And the blue one, Hmm, 3.76 ohms. That's a big difference. Okay, let's re-measure the red one again, just in case there was a bad connection. That's more like it, 4.19 ohms. You can see when it first powers up, it'll take a very large current, but it'll quickly warm up and the filament resistance will rise rapidly. Let's test the coil of the relay. From the manual I've seen that the coil was on pins 72 and 73, so let's have a look at that. 392 ohms, 677 millihenries. Pretty high inductance. Right. So as you've seen from the test today, pretty much all the components seem to be in good shape. I didn't show you all the resistors because that would be pretty boring, but they're all pretty close to the values that they state on the board. Some of them are a bit of a strange value that you wouldn't come across perhaps these days, like 500 ohms and 5k and 50k, but yeah, they're all within a few percent, which is fine for this experimental kit. Right, in the next one we'll build up one or two of the experiments and see how they work. Okay, bye for now.